An example of a reciprocal function would be Earth's gravity. So Earth's gravity at the surface is 9.8 meters per second squared, and the effect of the gravity is the reciprocal of the distance squared from the center of the Earth. And the center of the Earth, the distance to the surface is 6370 kilometers. So the function looks like this. The distance plus the distance from the center to the surface squared, so that's the reciprocal of the distance squared, times some constant k is equal to the force of gravity. And this represents the function, the force of gravity function, as a function of d, the distance from the surface of the Earth. So the acceleration due to gravity is given by this function. So we can calculate k by substituting in g of 0 equals 9.8. So g of 0 is equal to 9.8. That means that we have k over 0 plus 6370 squared. Solving for k then, we end up with 6370 squared times 9.8, and so the k value works out to be 3976,536,20. Okay, so it's a fairly large value, and they're going to save that value, and we're going to use that value to calculate part B. So g function then, as a function of distance, is equal to that constant value divided by d plus 6370 squared. If we want to find out the force of gravity, 1,000 kilometers, I think it's kilometers, yeah, 1,000 kilometers from the surface of the Earth, so we're 1,000 kilometers away from the surface, away out in space. The force of gravity at that point is going to be 39, this big number here, over 1,000 plus 6370 all squared. Working that out, we get 7370 squared in the denominator. So that big number divided by 7370 squared, the force of gravity works out to be about 7.32 meters per second squared. So that represents the acceleration force due to gravity.